glad to present some of my work that I have done before I joined Victoria University. And I'm mainly going to talk about the role of LIM kinase in cancer metastasis. Actually, LIM kinase is a serine protein kinase identified by Dr. Ora Bernard in 1994 from an olfactory epithelial cell lines at Washington Hall Institute. And she was my PhD supervisor. I joined in her lab in early 2000. Then I completed my PhD. Then I rejoined her lab several years later, that means in 2009. And I was in her lab till she retired in 2011 or 12. So I'm going to present some of the works that I have been done in her labs. Yes, actually LIM kinase, as I said, is a serine protein kinase. It is about 70 kilodalton in size, and as you can see here, the N-terminal part of this LIM kinase domain has two LIM domain with double finger LIM domain and then followed by a PDZ domain. And the C-terminal part of this protein has the catalytic kinase domain. And you can also see an S that representing the splice variant, and which is a catalytically inactive form, and it's known as LIM kinase short. And LIM kinase short actually acts as a dominant negative. And initially, the time when we identified this protein, we were known that this protein is only expressed in brain, and we call it as a brain-specific protein. However, with the help of monoclonal antibodies, we have identified that this protein is expressed in pretty much every single cell lines, human and mouse cell lines, as well as tissues that we have examined, but at various levels. And this family protein has actually two proteins, LIM kinase 1 and 2. Both are structurally similar to each other, but in terms of their location, they are different. And what does LIM kinase do? LIM kinase actually regulate one only known substrate, coffulin. Coffulin, I'm not so sure most of you know or not, maybe you know, but I wish to explain again. Coffulin is actually a smaller protein, it's about 20 kilodalton, and it's an actin depolymerizing factor. So when LIM kinase is active, it's indirectly regulate the actin dynamics by accumulating the actin filaments in the cells. So as you know that actin is expressed in all eukaryotic cell, and it's highly dynamic and involved in many cellular functions such as proliferation, differentiation, and migration. And the dynamics of the actin cytoskeleton is tightly regulated by many proteins, including sequestering proteins, capping proteins, proliferating proteins, and etc. And coffulin is one of the actin binding proteins that actually binds to the actin monomers and sequesters the monomers from the polymerizing end, as well as coffulin can sever or hydrolyze the actin filaments. So the main function for the coffulin is promoting the depolymerization. LIM kinase, it actually regulates the actin dynamics by controlling the coffulin activity by depolymerizing. So the time when I joined in Dr. Bernard's lab, we were investigated to find out which molecules can regulate LIM kinase activity. Here are the summary of the slides that you can see that LIM kinase activity is regulated via the downstream of Rho GTPases such as Rho PAC1 and PAC4. When these kinases bind to LIM kinase via LIM domains and activate the kinase domain, LIM kinase phosphorylate and inactivate coffulin. Therefore, we can see, which is on the right-hand side, that you can see the accumulation of the actin filaments in the cells because the phosphocoffulin cannot bind to the actin filaments. And my main PhD project was to identify the negative regulators of LIM kinase. So by using E2 hybrid screen, we have identified that the tail region of the bone morphogenetic protein receptor 2 directly interact with LIM kinase via the LIM domains, and these interactions inhibit LIM kinase activity by competing with its positive regulators. And other negative regulators that we have identified is actually a phosphatase known as slingshot phosphatase, and this phosphatase also bind to LIM kinase and dephosphorylate the molecule. And the third one is LIM kinase short, which I told you that acts as a dominant negative. When LIM kinase short binds to the LIM kinase, it's actually changed the stability of this molecule. Therefore, the half-life of the LIM kinase when it's dimerized, it's greatly changed from 20 hours to 4 hours. others identified that LIM kinase protein is highly expressed in metastatic cancer cells, and when we overexpress LIM kinase, that increases the invasiveness of non-metastatic tumor cells. On the other hand, when we express the dominant negative form of the LIM kinase, that inhibits the invasiveness of highly invasive breast cancer cell lines. So what you can see here, that LIM kinase is actually expressed at various levels in different cell lines. You can see that low to moderate levels are observed in 3T3, 293T olfactory, as well as non-invasive cancer cell lines such as LNCAP and NCS7. And on the other hand, you can see the expression levels are highly elevated in COS7, RAS transformed in 3D3, PC3, and MDA MB231. And when we treated these proteins, these cell lines with the alkaline phosphatides, we can see that higher molecular weight disappeared. And also, you can see that LIM kinase is nicely co-localized, or is in the form the focal efficients, and you can see that expression patterns in non-invasive breast cancer cell lines versus invasive breast cancer cell lines. So when we treated the cells with ROCK inhibitor for 30 minutes, the co-localization disappeared, the pattern disappeared, and here you can see that actin and LIM kinase localized, and they mainly expressed in the periphery of the cells. And as you know that coffulin is the only well-known substrate for LIM kinase, so we normally judge the LIM kinase activity by measuring the phosphorylation level of coffulin molecule. So we normally do that by checking in vitro kinase assays or in vitro kinase binding assays, as well as in cells we normally monitor the LIM kinase activity by probing for phosphocoffulin. And in parallel, we have observed that inhibition of cell migration, inversions, as well as proliferation. And in this slide, what I'm trying to show here is that inhibition of LIM kinase activity suppresses the cell proliferation and migration in vitro as well as in mice. So we had 41.2 red breast cancer cell lines, so we created stable cell lines by retroviral infection with the wave vector or LIM kinase, active LIM kinase, or dominant negative, and you can see the level of phosphocoffulin is greatly increased when we have when we let the cell line cells express LIM kinase, and it's when opposite when we have dominant negative. And we did the cell migration as well as inversion assays using vector alone or the dominant negative form, and you can see pretty much 50% reductions were observed that cells express dominant negative form of the LIM kinase. And similar results were observed for the cell proliferation in 2D and 3D cultures. That means that dominant negative inhibit the cell proliferation. We also observed the tumor volumes were lower in compared to the vector alone. So we actually cut the mice and when the volume reached 1500 millimeter cube, and you can see that the mice having dominant negative form of the LIM kinase is almost, it reached 1500 millimeter cube almost 1 week later. We also checked the metastatic state by isolating the lungs tissues, and we observed that slight reduction in dominant negative form of the mice, although they are not significant. And in that time, we were actually investigating to find out possible inhibitors for LIM kinase to downregulate this activity. And in the meantime, in worldwide, there are a number of drugs where people were investigating other drugs. And in our lab, we were working with following 4 drugs: CTX, BMS3, and PYR1 and 22J. And all of those inhibitors inhibit LIMK1 and 2 at same level. And actually, our lab was working with CTX, and unfortunately, we couldn't publish for some reasons. And BMS3 and PYR1 and 22J were available, and they were published. And we tried a number of experiments, and we collaborated with them, and we managed to get nice data. And what I'm showing here is the effect of cell growth and proliferation with the presence and absence of BMS3 you can see that cells grow in 3D cultures. This 41 cell lines, so with vector alone versus active form of LIM kinase, you can see without drugs, the active LIM kinase, the cells that has the active LIM kinase, they grow massively compared to the vector alone. And big reductions were observed in the cells that treated with BMS3. We also did 2D and 3D proliferation assays using the cell lines that treated with 1 and 5 micromolar BMS3, and you can see a significant reduction were observed in 5 micromolar BMS3. And the right-hand side, I'm trying to show that the level of phosphocoffin actually reduced when we treated the cells with BMS3. And we've done this in 3D assay as well. And then we wanted to find out that some similar results can be obtained in human cell lines. So we used MDA. So we treated the MDA with BMS3, and you can see the significant reduction in level of phosphocoffin. And in parallel, we inhibit LIM kinase expression by siRNA. So you can see that LIM kinase 1 is totally, totally down-regulated with the LIMK1 siRNA. And then we did in LIMK2, and when we applied the double siRNAs, we can see further reduction in terms of level of phosphocoffin. And then we did a 2D and 3D cultures to see the cell proliferation, and you can see that compared to the control, the cells that express LIMK1 and 2, they greatly reduced, as well as the cells treated with BMS3. And similar results were observed in 3D cultures. In terms of PYR1, PYR1 drugs actually were investigated by one of our collaborators in France, Dr. Laurent's lab, and they were interested to find out how we can inhibit tumor growth by inhibiting tubulin destability. So they were actually, because of Taxol has a large number of side effects, they were actually investigating to find out some other drugs. So they were screening, and they got PYR1, which can involve in tubulin stability, but when they did analyze biochemically, they found that PYR1 is an inhibitor, specifically inhibit LIM kinase. So we collaborated with them on that time, and we did an in vitro kinase assays as well as kinase binding assays to show that it's dose dependent and it's inhibit LIM kinase activity. So we did an in vitro kinase assay using ESD coupling as a substrate for LIMK1 as well as LIMK2. And you can see the level of phosphoLIM kinase were greatly reduced as well as phosphocoffin. And then we did for LIM kinase 2 as well. And then we tested this drug in parallel with BMS3 to see whether we can see reduction in phosphocoffin level in MDA, MD231 cells. And you can see that phosphocoffin levels greatly reduced. And also we checked the beta-tubulin, which initially targeted to find out whether PYR1 can involve in tubulin stability. Yes, the beta-tubulin level increased with the treatment of PYR1. The last drug what we were worked with 22J, this is actually we got from LLC company in US. Actually, they were using this drug to treat glaucoma in mice, and what they did again when they treated them with glaucoma, actually this drug inhibit, so it's improved. But then when they characterized and they found that it has some role in LIM kinase, so that time they contacted us and we worked for them, and you can see that again. With the presence of presence of 22J, 50% reductions were observed with the presence of 10 micromolar. And so far what we know that all these inhibitors inhibits both LIMK1 and 2 equally. And PYR1, which we collaborated with Dr. Lawrence, we were trying to see that mice survival. So we used the leukemia model, a mice model that we are in. So we injected PYR1 as well as vehicle, and we observed that almost 100% mice died at 70 days, but none of them died till 90 days. In summary, so as shown that LIM kinase is highly expressed in invasive cancer cell lines, and the activity of LIM kinase is also elevated in invasive cancer cell lines. And as we know that LIM kinase activity is important for invasiveness, migration, and proliferation, and inhibition of LIM kinase activity by small drugs can inhibit tumor growth as an invasiveness of in vitro. And whether LIM kinase inhibitors are potential anti-metastatic drugs is still in a question, because as I did show that elevated level of LIM kinase activity in most of the cancer cell lines, and we know that most of the cancer tissues are LIM kinase levels are highly expressed, although there are few papers that contradict to our findings that they did show in lung cancers that LIM kinase expression is greatly reduced. So it's a big puzzle whether it's a good anti-cancer drugs or not. And I would like to acknowledge all the lab people who worked with me the time when I was with Dr. Bernard, Dr. Rockley, and Dr. Carla, and Dr. Victoria, and our RMs naturally, and our collaborators, Dr. Lawrence, that we collaborated for PYR project, and Dr. Robin Anderson from Peter Mac, we collaborated for BMS project.
Okay. Thank you, Juliana. So, any question or comment for Juliana? Question? I have one question.
Yes.
Since you have tested 4 different type of LIM kinase inhibitor, have you tried to test all of them on some so-called normal cell to see any toxicity?
Good question. So
yes.
for normal cells, what we did, we overexpressed the LIM kinase, then we tested, they went down. Yes.
But
so
if for
the normal cells, when we apply these drugs, the level of phosphocoupling greatly reduced.
Okay.
Okay. So
That's
when
good.
we overexpress the LIM kinase in normal cells, we tried the migration and proliferation assays; those went down.
Okay, that's great.
And they were similar observation what we observed when we knocked down LIM kinase by siRNA. It was pretty much same. So whether we downregulate the expression or whether we downregulate the activity was this.